This video provides an introduction to modeling with SPSS Modeler. The ability to predict an outcome is the central goal of predictive analytics, and understanding the modeling process is the key to using flows in SPSS Modeler. For example, a financial institution might use a model to predict whether loan applicants are likely to be good or bad risks, based on information that is already known about past applicants. This example uses a decision tree model, which classifies records and predicts a response using a series of decision rules. Open the sample SPSS Modeler project. In the project, you'll find the treecredit.csv file used in this video. The data in this example contains information about fictional bank customers, including their credit rating, age, income, number of credit cards, education level, and the number of car loans the customer currently has. Using a decision tree model, you can analyze the characteristics of the two groups of customers and predict the likelihood of loan defaults. Open the Introduction to Modeling flow. The first node is a data asset node that reads the data from the CSV file that's stored in the project. The type node specifies the measurement level for each field. The measurement level is a category that indicates the type of data in the field. The source data file uses 4 different measurement levels. A continuous field contains continuous numeric values, such as the age field, while a nominal field has 2 or more distinct values like the education field. An ordinal field describes data with multiple distinct values that have an inherent order, in this case, high, medium and low. A flag field is typically used for binary values. In this example, the values are bad or good. For each field, the role indicates the part that each field plays in modeling. The credit rating field is a target, or the field you want to predict, which indicates whether or not a given customer defaulted on a loan. The other fields are input fields, or predictors, whose values are used by the modeling algorithm to predict the value of the target field. In this example, you're using a chi-squared automatic interaction detection modeling node, which is a classification method that builds decision trees by using a particular type of statistics known as chi-square statistics to work out the best places to make the splits in the decision tree. Here you can specify the objectives to indicate the kind of model you want to build, and the stopping rules which limit the tree growth. Now you're ready to run the flow. Running the flow generates a new model nugget on the canvas. View the model details. The top decision rules displays a table containing a series of rules that were used to assign individual records to child nodes, based on the values of different input fields. The feature importance chart shows the relative importance of each predictor in estimating the model. From this, you can see that income level is easily the most significant factor, with number of credit cards being the next most significant factor. The tree diagram page displays the same model in the form of a tree, with a node at each decision point. Hover over branches and nodes to explore details. The first node provides a summary for all the records in the data set. Just over 40% of the cases in the data set are classified as a bad risk. This is quite a high proportion. So let's see if the tree can provide any clues as to what factors might be responsible. The first split is by income level. Records where the income level is in the low category are assigned to Node 2, which contains the highest percentage of applicants who have defaulted on a loan, which places them in a higher risk category. However, almost 18% of the customers in this category actually didn't default, so the prediction won't always be correct. No model can feasibly predict every response, but a good model should allow you to predict the most likely response for each record, based on the available data. If you look at the high-income customers, you see that over 88% are a good risk, but more than 1 in 10 of these customers has also defaulted. So, the next question might be, how can this information help the bank to refine their lending criteria to minimize the risk? Notice how the model has divided these customers into 2 subcategories, based on the number of credit cards held. For high-income customers, if the bank lends only to those with fewer than 5 credit cards, it can increase the success rate from 88% to almost 97%, an even more satisfactory outcome. The medium income category is much more evenly divided between good and bad ratings, so looking at the subcategories can help. This time, lending only to those medium-income customers with fewer than 5 credit cards increases the percentage of good ratings from 58% to 86%, a significant improvement. To evaluate how accurately the model works, you need to score some records and compare the responses predicted by the model to the actual results. In this case, you'll score the same records that were used to estimate the model, allowing you to compare the observed and predicted responses. Connect the model nugget to the table node and run it. When the run is complete, open the output table. The table displays the predicted scores in a field named $R credit rating, which was created by the model. You can compare these values to the original credit rating field that contains the actual responses. As expected, the predicted value matches the actual responses for many records, but not all. You can see that the confidence score is lower for those incorrect predictions. Remember that there were 18% of low-income customers who did not default on their loan. To find out exactly how many predictions are correct, you can use an analysis node. After you run the flow, open the results. The analysis shows that for almost 80% of the records, the value predicted by the model matched the actual response. Lastly, you can use this model to predict the outcome with a new dataset. To do this, you'll change the data asset associated with the data asset node to the new data to be scored. When you run the flow again and view the table output, you'll see the predicted credit rating and the confidence score for that prediction. Now, you're ready to explore more tutorials and videos in the documentation.